Athena, bit of Athena, I think, yeah. So we'll start with some tools and languages from there. Yeah, so I think tools, if I would say, I will explain some more tools which you typically use, and then we will actually go to our learning session of language like PiSpark and Scala also. So like okay, if I list out the tools, say yeah, I will explain some more of Athena stuff. There's like some more stuff, and even Glue, there are some more functions available. These are like very important tools for data engineers. Then and after this, I think Lambda also use Lambda function. Then I will actually like walk you through a couple of them so that my goal is not to confuse you, but to record it so that when you watch the recording, you can also like explore and rewatch it so that you can get familiar with it. So I know that when we go to new tools, it is very confusing, right? So I will try not to do that with all that, but when you record it, you will be able to see it again. And I would recommend like watch it again also so that you can be familiar with them. So couple of more tools that are we typically use. S3 we covered, right? S3 something use RDS, Redshift, and Glue. Then Glue also we are going to cover some more. Then Lambda, and after this, yeah, let's see. I think some more tools should be there which we can grasp. Let me share my screen. Let me share. Okay, so if I go to Blue is the first one, we cover some more stuff there. If you remember, like we cover crawler, and we also covered database and tables. So let's cover some more. Athena, and S3 we covered. Then let's see if we have some more stuff. I think what happens like network on this time is like becomes very slow. All the, I mean, otherwise it runs good. There is some issue at this time maybe. Yeah, cloud formation, I think this also sometimes use for infra as code and all that stuff. So, and then IAM also we use. Then let me show this also. And Lambda we discuss, and all these are like sometime. So whenever I use a tool a lot of time, I simply like also we can bookmark it. So we just go to that tool and you will find that you will get some kind of icon. You can even bookmark it. And yeah, I mean S3 we covered. Then let's understand some more services of Google. Those are also we use regularly. We need to again, I think, just give me one moment. I'm trying a different network. Yeah, crawlers, right? Crawlers is something, think you cannot see it yet. Yeah. So crawlers is something which we use, like they are something which help us to like ingest the data, all that thing, like initial part where our data is stored in S3 and crawlers go there, understand the schema and register to our database and tables. So this part we covered. Then schema registry is, I would say these two are not we use, but sometime, I mean hardly one or two time even I use them at some moment, but it's not regularly that we use, and we can keep it out of context. Like database are very important, crawlers are important, and then we call it catalog also, like data catalog. So when you add something here, this is called like your catalog, so that you have multiple databases in catalog. So that's their way of saying it. Then another service which we use is this one, which is like ETL jobs. So click on this, you will move it to another window where there is like, this service is another like a major service, I would say, where you can build ETL pipelines. So where, I mean, they provide you some kind of computation like Spark, Python, all that language also you can use. So for example, if I show you one pipeline like this, yeah, so you can see that like we can visually design our job, and we can decide the input and output and what happens in between. You can add, I mean, you can create as complex as you want your pipeline. So visual designing is there, but still we can also directly write the code. And from this visual also, they provide you some code. So this is like the code, PiSpark code that we get out of it, and this is the code, we can run it and we can even customize it. So in some cases we do not rely on visual also, but we even customize it further as per our requirement. So, and this code is, you can choose either to use Python or Spark, but Spark is a general language that we use. So you know that Spark is again, I mean, PySpark is obviously based on Python only. So all the familiarity and all only new terms you will find. For example, you can see that some more libraries are new which we haven't used. Sys we might see earlier, we use it also, but otherwise like AWS group pip, and that library we are importing some context. Then from PySpark, we will learn about this, like this is something we import. And otherwise AWS glue is like something we are using to import like multiple things. And this is like the code, which is also a bit different, but its structure is same because it's like again Python. So that is something we are doing here, taking some input from this database table, right? And doing some mapping, which is like I'm saying this particular column is string, this is string again, all that. And once the mapping is completed, I'm writing it down into S3 path, and also registering. Registering, I think, is not doing, we can also do that. But here what we're doing, we are saving into Parquet format in this location. So that is something we are doing. Okay, so this is like the job that we can create, and this is again a service which we regularly use. I mean, for any kind of compute. So if somebody asks you, like, what is the option to like run some compute? So we know that Glue ETL is one such thing which we can easily use because it is serverless. So you don't have to like create your own clusters then run your jobs. No, you can easily like create a job and that's it, you can simply run it. And a special thing is that it is PySpark and you even get a big cluster size. So if I show you here, you can customize your settings here. So for example, you can see that worker type is this one, 4 vCPU and 16 GB of RAM. So this is like one type of worker. You can pick another one also, like double of that, 8 vCPU, 32 GB RAM, and you can decide how many workers you want. So that is something you can mention here. And I think generally I pick 10 workers only because it's again it takes cost, right? So sometimes even I use 2 3 worker also, 2 3 4. So you know that why PiSpark we use. PiSpark is something which can distribute your job, like the total workload. So it's like if one worker of this machine can complete the job in 1 hour, then obviously if you increase the worker, the more workers you increase, the faster it will complete, right? That is something which is like a superpower that we use in today's world. So you can increase the worker here. I think not sure what is the maximum limit we they put. Say if we put 100, so it's like um 80 800 CPUs you are allocating, and it's like the how much TB, it's like 3.2 TB, that much of RAM. So it's like super big cluster, right? So it's like something you can easily allocate, and you can compute huge data also like this. So it's like that way we use it. And also other features are there like timeout, number of retries. So all those actually are good features that we can use. Then this is like another service I would recommend, which we use a lot of time. So it's like three services. One is crawlers, another one is database, and the third one is ETL, which is like this tool, Glue Studio tool. So this is like glue, we call it glue jobs or glue ETL jobs. But this is like three services I would say we use in Glue. Then yeah, I think other services are not that much good. Even interactive session notebooks are same. So instead of like writing directly the jobs, you can also allocate some Jupyter notebooks in cloud. So it's like this service can give you notebook, and that notebook you can interactively develop your code. That is what we typically do. But in my case, I use Databricks also a lot. So we will learn about Databricks also. So that is something is another very good service for development of Spark jobs. But yeah, this one is, as I explained, like you can also use this one to develop these jobs first and then deploy it here. Something like that we can do. And also scheduling is available. So it's like you can schedule your job. So maybe every day you can run the job on new data, something like that we can do. I think other than that is not important. Only focus on the GlueTL jobs, and then crawlers and database tables like simple that catalog. So it's like three services I would say are important inside a single Glue service. Then in Athena, you know that what we use it for. So it's like getting some data out of it. So whenever you add some database there, you will also see here in this list. That is something which happens. And then there are more features also in Athena. So it's like all the databases are exactly same which we saw there. Then there are more features also. So one feature they recently added is explanation. So whenever you run some query, you can also get some explanation of that. Remember in our SQL class we mentioned one keyword explain to optimize the queries and all. This is exactly that. So in Athena also, they, I think I attended the workshop also on that, but not used in practical. But yeah, the workshop seems very interesting. So they actually provide some like kind of breakdown and all in like very nice charts. So I actually like very impressed with them. Like they are providing all that planning and all. So it's like output, but you to start from here. If they are scanning the table, then we, because we set the limit of 10, then they're gathering, putting something here and there, then showing the output, something like that. And I think there is some like a flow also. That flow, if I not here, I think maybe directly in that plan they share that. Somewhere there is like a very nice chart also, which we get. Maybe if I try directly, not here, okay. I mean, yeah, something like this. So it's like you can also see like when we run the query, the how many like different stages, what is the total percentage of time. So it's like first of all our query queued, and that takes like 12% of the total time. And then because it could be like sometimes query could take 5 minutes also, right? That is very typical. So we want to understand like where those 5 minutes are going. So right. So you will see that why, I mean, which step is taking time. So this combining this and explanation, you can even like optimize the query further, because they even in workshop also I noticed that they explain all this process, like how, I mean, they even take very good example and all, that how they optimize some queries here and there. So if you're interested, I can also like find that and share that workshop and attach in somewhere so that you can see that. But yeah, I mean, that was the whole purpose, where they wanted to show, I mean, showcase their feature, something like that. So they explain like, okay, the planning is taking long. Then they analyze and revise their query to include some more filter on where condition, or maybe I think they at one time use some subquery, and they mentioned that if we write this kind of subquery instead of that, or CT, common table expression, instead of subquery, that will optimize the speed and all. And then we can even see it here that graph and all reduce. So because of this, like they notice that execution taking time, or this taking time, or this taking time. So it all depends like which is the time taking operation. So it's all the features of Athena which they provide, and not only like glue, but there is a feature to like include databases, multiple databases actually in Athena. So that is also, I think, in one very vast workshop I like covered all that features and all which are dedicated to Athena. But here that is like one feature. It's not only S3 bucket and glue, but Athena can like query all kind of data. And another feature is like it is serverless. So it's like we don't need to again maintain any server. This is totally serverless. We just come here and run our query, right? So that is again one feature. In terms of Postgres, Redshift, that is not the case. I mean, obviously, Redshift serverless is new feature which is solving that problem. But earlier, we need to start the cluster, and even in today's world, I mean, RDS Postgres is still we need to create a cluster first, and then we can use that. But here is not the case. We can simply run it, and server is something which we don't have to maintain or manage. Then another feature is like you can save the query. We can save, and that query will come here in the saved queries. Then all the histories also they maintain automatically. And I think these are all the features which they provide. Yeah, I think these are like all the, and you know the technical thing also, like this Athena is kind of a managed version of Presto. So Presto engine is just like any other engine, but is very advanced. So um, basically that is developed by Facebook, and they release in open source then. And then Athena is a managed kind of thing of that thing, Presto. So remember that also, if somebody asks you, so you can mention it that it is based on the Presto database engine. It's not like they have their own engine, but they used open source engine to create this kind of service. So that is one technical thing. Then this is the server thing. And then yeah, CloudFormation stack. So what happens, we can create different stacks, and that stacks we can like list out here. So it's like we can if I show you one stack, I mean, this is like stack means, if I say stack, that means let's say you want to create a whole infra out of 10 services, 12 services, or 50 services in some connected way. So you can convert that whole infra into some kind of a script, so that anybody can copy your whole script, which is a simple file, JSON YAML file. And that file is not a code. It is not something which is doing the coding stuff and application processing. No, it is an infra code. So it's like the whole infra means different set of services. For example, let's say in your application you are creating two S3 buckets, and then one Lambda function, one Postgres database, one Redshift cluster. Then you're inserting something into those databases, and then all that operation you can include. So whatever is the infra or application plan, you can include all that in a single template as a code. So therefore we call it infra as code, or in short IAC. So in interview also they might put you in JDs also like IAC something on that side. So that is like what CloudFormation do. So that is like a service, which is again great service to create all kind of stacks or infra. And then another which is not AWS specific is Terraform. So Terraform is also is very popular, even popular than compared to CloudFormation, a lot popular than CloudFormation, I would say, because I see only that most of the time. But still, when you are using AWS, you will use CloudFormation because you can do anything, any kind of stuff with CloudFormation also. So that is something we use. But Terraform, I would say, is cloud agnostic, which means it runs on all cloud like Azure, GCP, even other clouds like which are specific to some services like Confluent and all, and AWS. So Terraform runs on all. So it's like one good tool which people use. But otherwise, CloudFormation also is more than relevant for like deploying stacks. We can define it. So if somebody asks you, do you know Terraform? So we can say that no, but we know CloudFormation and we can do that on AWS specific services set. So it's like competitive. It's not like it's that, but it is equally competitive also when it comes to AWS inference services. Then another one is, I think this one is IAM. IAM is another tool which we use, but this is not, I would say, dedicated tool for only, data engineering, but it's a generic tool which we use for all kind of maintenance, like kind of governance. So we can control everything, like all kind of access. We can decide who can control what. So if let's say you are hiring someone as in your team and you want to give them only access to Redshift cluster, and let's say you are running 3 clusters. So if you want to give only access to one cluster, right, any one of them which you choose, you can even control that, like you can assign only that kind of access to the person. So that is something we control here, like who is accessible, which service accessible to which person. And also, I mean, this is all about that, like creating. So when we say policies, policies actually are like a document where we mention what this policy allows or denies. In policy, for example, in S3 bucket also, let's say you want to give control to one S3 bucket and not all. So in policy, you will create a policy where you will mention that you can, I mean, name it anything, the policy name. So it's like, let's say we are saying data engineering training policy one. Let's say this is a name, and that is giving access to one particular S3 bucket. So that is one policy, and now we can attach that policy to any role or user. So these are two called actors. So they are the like entities who act, and their access, I mean their power, is decided by the policy. So policy will decide what the actor can access. And the users and roles are actors. So they just act based on the policy that are attached to them. And similarly, also like multiple policies we can create. One policy is maybe for one S3 bucket access, another policy for accessing Redshift, something like that. And then we can attach policies. And these are two independent things. That means once you create a policy, it's not like dependent on any of the actors. So it's like you can use that policy to attach to any of the roles and users, multiple of them also. So it's like policy just to deciding what is allowed and what is denied. And users and roles are like they are the actors. So users are like people, for example me and somebody else also. And roles are not actual users, but they are someone like a hypothetical person. So it's like and roles are also important in organization, because what happens, like if you create a role, then anybody can assume that role, right? Maybe me, my teammate, my other teammates, manager, or some other team also, they can assume the same role. So it's like role based control. So that is something which is very important in organization, because if person leave, then we have to change everything, right? So instead of that, what we do, we create a role, and anybody who is working in that role can assume that. So it's like independent of the person then. So person can leave the company or join the company and all that thing, and role will be there as long as you want, right? So that is something where we use roles. And another reason for accessing role is sometimes we want some service to play the role of an actor to access some other service. For example, if you create a Redshift cluster and you are planning to get some data from S3 into that cluster, so now you create a role which will like be able to like access the, so the Redshift, we attach a role so that Redshift can play the actor role, where they will be allowed to read the S3 bucket. Something like that also is possible. So all that is something we do here, all kind of control on that side. Then this is another service, EC2, and the full form is Elastic Compute Cloud. So it's like double C, therefore they call it EC2, like ECC. So there, I mean, any kind of virtual machine on cloud. So it's like if you heard about like VMs, right? Compute. So those compute you can easily create on cloud. So EC2 is all about that. So whenever you create some compute engine, you can use the EC2 service. So like for example, if you need 16 GB machine with this much space, let's say 1 TB of space, and then 50 GB of RAM, all that customization, you can easily allocate the instance for that. They call it instance. So for example, in my case, you can see that I have two instances which are like at present available. So that means there are two machines which I have, and they will maintain the state. So I created them like months ago, and still whenever I need to use some compute, for example, in Docker is something which in my system actually they create very difficulty to run because of space. So I use the cloud services for running the Dockers and all that thing. So the interface is exactly same. You have full power. As long as you hire the service, you are the owner, right? So it's like whenever you are using the service, you are the owner of that machine. So it's exactly like you buy the machine like from the market. So it's like that. But instead of actually buying the service by using huge investment, you are just taking on rent here. So it's like taking a rent on cloud. So it's like you are renting the service, compute and on, and then you can use it and then again release it. It's like that. Now what is happening? Like the actual processor, RAM and all are not available. So these means only the state is maintained, somewhere stored. And whenever I start one of my machine, what will happen? They will find some available um processor, RAMs, and all that machine, a proper virtual machine. They will allocate all those hardwares which are free somewhere in the world. For example, if I use this region, North Virginia, so they will find in this data center some available resources which I mentioned, and then transfer my machine state to that particular instance or that particular resource. So that way I will be able to use again like a virtual machine or a hardware. So that is some and I mean this is again one of the core service EC2, but I mean generally it is good to know, but also like sometimes I mean we do not directly go here and create our machines. So what happens, like if you use some other service, they internally create it for you. That is also possible. But yeah, it is something we should be aware of about EC2. Then comes Lambda. Lambda is again a compute, serverless compute, just like GlueETL. In GlueETL, you might notice that it's for big data. Now, what happens if your compute is for limited, like only small kind of compute? So what you will do then? Like let's say given number A and B, you want to compute the add. You want to add those numbers and like return the number on like something simple like that. So if you use Glue and you like write your job there, so those are designed for big data, right? I mean, so based on the simple operation that will perform, your cost will also be greater, and the startup time and all that will be as per the big data only. So what happens, sometimes we need some small kind of operations also, very very small. So for those, Lambda is available. So Lambda function is again a compute where you can write your Python code, and then that Python code you can run serverlessly. So we don't have to start any cluster, nor not at all. We just have to write the simple code of, let's say, adding two numbers, and then we can deploy it. That's it. So anybody can, even we or anybody who is like want to consume that function can use that for the operation. That is again a compute kind of thing that we use. So again, it's very good to know that there is another option to compute for like light stuff. It's not like those are two things which we need. Sometimes we need heavy kind of transformation, sometimes light transformation. So for light transformation, Lambda is best. For heavy transformation, ETL is good. Then there's another service called secret manager. This is again, I mean, I think, yeah, we used earlier also. So that's it. I mean, these are like some services which we typically use. So if I share that tools again, yeah. So I think we are good with tools then. So if you have any question, you can ask, and otherwise, these are all about tools, and we can start the PiSpark then. If I, okay, yep. Okay. Okay. Yep. So after, I would say after this one, let's start the PiSpark then. So if I go to curriculum, yeah. So you notice that, yeah, I mean, we have foundation, then the basics foundation of data engineering, then we cover this one, tools. So after the tools, the next target is to, like we covered the Python and SQL earlier, and now we are targeting two more languages. But that is something you can ignore also. So that is something, I mean, you can let me know if you want to like skip it, and then we can skip it also, because if you are not good with Python plus SQL, then it will be difficult to, I mean, it is no advantage of using another language or learning that if we do not know the Python and SQL. So that is something which is priority for data engineers role. So let me know if you like, because it will be again difficult also. So it will not only like increase the load of learning something new, but again it is also complex compared to Python and SQL. So that will even be increase your complexity of like total learning material. So that is something I would recommend only use or jump if you are comfortable with like Python plus SQL both. That is a priority in jobs. So I'm starting the PySpark first. And for PySpark, I would say, I mean, locally we can install. In my case, I install locally, but the recommended way, the best way even I use is by Databricks. So for Databricks, what you need to do, you need to go to Databricks Community Edition, and here you can sign up. For example, like this. Once you sign up, and they will not ask you for any kind of card, credit card, debit card, but they will simply ask you to like fill a form, and after that you will get the link on your mail also. So but you just need to go here, community Databricks, and there you can simply log in like this. It's a free account, and there is no limit of time also, and no limit on like resource also. You can keep using the resource as long as you want. So for me also, like this is the login credentials I use, and once I sign in, you can see Databricks is, I mean, now they are a lot more. They are providing new and new services, but it's like the one of the good tool to run kind of a Spark things. So it's like managed Spark. So once we go to Databricks, first of all, we go to compute. In compute, we need to create a cluster. So we go to compute, let it open. Yeah, after go to compute, we create a cluster. So for creating the cluster, I mean, cluster is just like a, I would say, a collection of resources or virtual machines. So what happens when you create a cluster? This time it is like community edition. So it is hosted on their servers, and therefore we will not know or can see the, I mean, those kind of machines. But when we create a cluster on our own kind of hosted environment, so there we can even see that I create a cluster here, and the EC2 where we create the compute instances and all, those are actually, I can see that the database internally create all those machines for me. I just need to like, from this simple GUI, I can say Jan 11, and this is like a versioning. So once you provide the cluster name, you also like provide the version. So by default, this is the best way. So we can select that. And the second kind of series is for machine learning. So machine learning provide you GPUs also. So that GPU is something we don't need. We just need without GPU machines. So that is something we are selecting here. Then they provide you, I think they are, I mean, this is something wrong with their system, like I think GUI, because it's like something like this. This is actual memory. So we use, I mean, in free instance, we get this much of memory and 2 cores of processor power. And then what happens whenever you develop something here? You just need to increase your cluster size, and that's it. The for big data, as the data increase, you keep increasing your cluster size to process that data. And from the code perspective, there will be no change. That is the logic here. Like whatever we write here is totally production ready also, because in production any kind of workload can be handled by that same code. There is no need to change any code. So here in Spark, what happens, like we have one driver and a large number of workers. So driver maintain the job distribution, like which worker handle which job, and they divide the work and also like control all the management thing. And then workers do the actual work. So it's like they compute everything and all. But if workers are not there, driver can also, because they have the equally compute power, they can also do the same work. So it's like first they allocate all to all the workers, and then they also handle some workload. In this case, in a free community edition one, you do not have any worker. So it's like a single node. We also call this kind of thing single node cluster. So it's like only one node is available. So there is no distribution of the work, but still, if you increase, like say, there are one worker or 10 workers, 100 workers, so it will not matter. PiSpark simply keep distributing the work among the workers and drivers. So it's like that. And I mean, that's it. We just provide name and create the cluster. So it will take few seconds to create the cluster. I mean, they allocate the machine behind the scenes, they install all the required libraries there, and then they give you some kind of checkbox like the cluster started. So after that, the second step will be to create a notebook. So I will show you that. I mean, keep it open, and we can even see in our notebooks also that cluster created or not. So I think I already have a couple of notebooks earlier I created. So one is, I think, which one is the base one? If we use, yeah, I think this one is also M&M count. So I will explain couple of Spark code also that we can use. So here this is called notebook. Notebook is just like Jupyter notebook. So here even I feel that their notebook is even better than Jupyter notebook because they have more power. So they have collaboration capabilities. You can publish it also. Then and there is like multiple cells, for example, markdown cells like this. So I mean, overall, you will feel that you will not face any kind of, I would say, any weakness in this notebook. It's like all good. So it's like you can write the Spark code in this. So for writing the code, first of all, when you create the new notebook, let's say if I create a notebook, just create and notebook. They will ask you the name of the notebook and then on which cluster you want to attach it, and then the language. And it's not a permanent thing. You can keep changing the cluster also. It's like a notebook we can create and then attach to any of the cluster you want. They are just asking for the initial one, like when you create the notebook, do you want to attach it to some cluster or not? So this is a cluster they selected automatically because this one is the only one available. So we are saying yes, we want to connect. Earlier one also, I think I created earlier. So they are also showing that this one is active. You can see the checkbox. And now once we select the cluster and the language, there are 4 languages available: Python, SQL, Scala, R, and Databricks support all 4. So again, this is optional because they are just saying by default, when you create a new cell in your notebook, which language you want to create that cell in. So I'm saying by default, keep it Python, but we can easily switch it to SQL, Scala inside cell, like particular cell we can dedicate to other language also. And the name. So name is something you can mention here. Then if I go to this one, this MNM, so I think here is one of the basic code that we go. So it's like from here we attach to our cluster like this, and once we have our cluster ready, this chain 11 one, then we start executing our code. So it's like here what we are doing, I think yeah, there is one more thing which is same. I mean in local also you might notice that by default obviously it is Python shell, but you can also use some bash command. To run the bash command, you have to write this kind of thing, exclamation mark. So here what I'm doing, I'm saying create a cluster, right? This is a bash command. Now you can see why we sometimes need like a bash knowledge also. So here we have like make the directory, and this is a location. Location is like root and tmp folder and vist2. So this is a location that I am creating, and then I'm creating a folder of this name. Then I'm using another command. This command is to download the data from somewhere. So I'm saying from this path, download the data like this, right? And once you have the data, this particular data, MNM data set, we are outputting it to this file, which is like tmp, the location we created, and the file name. So we are saying, I want to download the data from this link into this file. It's like these file and this file, this file and this file is like in sync. They are same. We are downloading it from server to local. Then after that, this one is specific to Databricks. You will not find it anywhere else. Is like what we are doing. There is a system, file system called DBFS, Databricks file system. So what happens? Just like a regular file system, Databricks has its own file system, which is distributed and also like optimized as per the Databricks operation, Spark operation. So we need to like work with DBFS when we need to work with Spark. So when you download something, by default, it goes to the file system, which is like this. And we need to manually move it to DBFS system. So that is like the operation we need to perform. So what we are doing, we are saying from the file system, where the file is this, I'm moving, and there is like Databricks utils. They have some default utils available. One of them is for file system and move. We are moving this file to this file. It's like same, right? The path is same, but we just changing the file system here so that our path will not change, but we are moving into different file system, which is DBFS. Once we have the movement available, and then we are trying to list it out. Here we are saying fs ls list, and then we are passing the folder. Then we are getting the information that file name is available like this. Then this is a Spark operation now. So first of all, what we do, we import some module. So this is one of the important module that we do. So import PiSpark dot SQL dot functions. So as if, so this function provide us some predefined functions like count or extraction, all that thing. So they basically provide all those predefined functions inside this module. So we are defining, importing that one, and then also we use this, which is like a variable where the data is available. So you know that, I think mount file, MNM file, I think it's not exactly mesh. So what we need to do, we need to, it's like that, because our data is like this, right? So it's where the data is stored, because here we can notice that our data is like this. So this is the data where our data is available. Then the first step to read the data from CSV is this. This is the same command. You will notice that we will use the exactly same command everywhere to read the data in Spark. Just like we read the data in Pandas by pd.read CSV in Spark, this is a format to read the data. Use Spark read format CSV. And then these are like options we can provide. So it's like option header true. So that is again a way in Pandas also to say that the headers are available. The first row is the column names. And then infer schema also, you can infer the schema. So it's like again, Pandas also try to infer the schema, right? Here also we are trying to infer the schema automatically. For example, we are trying to, Spark will say this is integer, this is string, these two, something like that. And then the path with load. So once you do that, this is the loaded data frame in PiSpark. And in the feature perspective, I would say that one feature of Databricks Notebook is they provide some HTML support inbuilt. So it's like you can see that the table is not limited to only the print. It's like inbuilt table with thousands of rows, right? By default, 1,000 rows is they print. So it's like good navigation we get. Then once you load the data, it's time to apply some operation. So we are applying here some aggregation operation. So we are saying select the particular columns, then apply group by, and then taking the count. So it's like how PySpark is something we write here. So it's like select some columns, then group by state and color, and then we are saying aggregate. So you know that in Pandas also, this is how group by works. We first select some columns if you want, and then on top of that, we use the group by aggregation. So it's like group by, you can, group by only one also, but here we are grouping by state and color both. And then we are saying after grouping in each group, what kind of operation you want to apply. Is it sum, count, mean, max, average, what? We are saying aggregate, and the count function is actually the, if you remember, we imported f earlier, right here. So that has some predefined function. One function is count. So that is how we use that function, that predefined function, to like provide the this particular thing like count. We are naming it count, and we are saying that I want to count based on the group. So basically like the remaining column, which is count. I'm saying group by these two columns, and in each group just count all the records. And that way, alias is another term which is not available in Python. Here we call it to rename the columns. So we are saying whatever column you get, just name it total. And then also optionally you can order by. So ordering by total again. So it's like ascending false. It's again optional flag inside order by, where I think you can relate also to SQL. In SQL also we do some of these operations like group by, order by. So it's like almost same, because PySpark also they actually like not only I would say Python and Spark, but a lot of influence is also coming from SQL. So you will notice that a lot of similarity with SQL also is available here. So we are saying ascending false, that means in descending order. And this is like how we print with show command. In show, you can also say that how many records you need. So printing 60 records. So this is a final output after aggregation. So from this table, you got this table, right? I mean, you can see that all three columns are here also, CA green, but this time you aggregated the total count based on these groups, shade and color, right? This is the operation we are doing in Spark. Then another one we are doing something similar, but here you can see that where is new. So we are selecting, then we are putting the where condition also to apply some filter. So only Texas is available, and then again same rows. So this is like the basic to operation stuff that I explained. So I feel it like this particular piece is nice way to start Spark. It is not complicated and also challenging enough to like learn some concept here and there to getting started with Spark. I hope this one is something you understood so far. And if you have a question, you can ask. Then after this, so this one is also very, I would say, good enough to explain also. So some operation you will find common and some more will come which are not used so far. For example, getting the file is fine here, but this time we have a gunzip file. So first of all, we are unzipping that. So this is a command we use, gunzip -v, to unzip the gunzip file, which is like create it, remove this dot z's, and then also increase the size because gunzip compress the file. So it's like we are uncompressing it here and again moving it to dbfs. So once we do that, then we are also like this time not we are not doing it from that side, like from f we are not saying import PiSpark SQL functions as if we are saying import all the functions from this particular module. So it's like instead of writing f dot count, we can simply say count, which I would say is not a good coding practice, right? It increases confusion. So I prefer that way, like from PiSpark SQL function, import that as f, so that f dot I can mention. But this also you will notice that some coders and all that, you will notice this kind of code also, which is very common. So therefore I mention it here. And then types. So here in this particular thing, we will also work with schema. So for schema, we use the SQL types. So we'll see. So first of all, we are just checking the head of our CSV, how it looks. This is the head of the file. And then this is the schema part. So what we are doing, we are saying that, okay, it's like we have 4 million records. And then we are um, mentioning a point. We are saying that if we try to infer the schema, and that is a very common problem that when we infer the schema of using PiSpark infer schema feature, on big data actually it's very time consuming, so we don't want that, and therefore we remove that in case of big data. Only for small data we use that feature to understand the schema. Otherwise we use the manual process like to create the schema ourselves. That is a faster way. So here what we are doing, this is a way to create the schema. So schema means, I mean, we define column name and column type, that's it. So here we are saying a struct field, you will notice that everywhere you're mentioning that. And then these are like the type that we imported earlier. This include actually everything, struct type, struct field, integer, float, and all that type. So here we are simply mentioning this format. The third one you can ignore because they is like nullable. So we are saying nullable is true in all the cases, but sometimes we have restriction also that this particular column cannot be null. In that case, you make it false. Nullable, false. Otherwise, generally we keep it true also. Then the first two are like the column name and the column type. We are saying the first column is call number and then the type is integer type. And the same way, the structure is exactly same then. Only the type is differing. Some are integer, some are string, and some are float also. Yeah, this one float. Yeah, some are float, integer, and string. Yeah. And then I think a boolean is also, I can see one boolean. So these are like 4 5 types you're mentioning here. I think double is also one of the double type. So types and all in documentation, you will notice that there are other types also. You can refer to those. So once we have the schema available, so struct type basically is a kind of wrapper working as a wrapper, and that wrapper we are saving in this variable fire schema. And now you can see that we are doing the same, like Spark read CSV, and then the path header equal to true. But this time we are saying the schema also. We are saying schema is this one. So that way you can get the data with the correct schema, because schema actually what happens, instead of inferring, which is time consuming as you mentioned, you can even infer the schema. I mean, you can mention the schema and put that schema while loading. Now your data frame is loaded correctly. And then cache is also like good, because we are mentioning that because I mean it increase, I mean the performance sometimes, because you can cache some of your databases and data sets. Then this is an operation you generally see, like count. So on data frame, if you want to get the total number of records, how many rows are there, so you can see that records like this, there are total count available. Then this is again general command we use, print schema. Here we are saying what is the total, I mean whatever you write in schema, that is coming here. So you can see the schema also, print schema command is there. Then again, this one we haven't covered before. So what we are doing, we are actually like limiting our rows to only 5. And then also this one is a kind of a function which is available. We can pass our data frame here, and they display in this kind of table display. Then we are applying some operation. We are like, this is a condition we are saying. We are saying that for this particular data frame, I want to select some column, and then I want to apply some where condition. In where condition, I'm saying where the call type is not medical incident, only those records will come. So you can see that this kind of print we can do. And then what I will do, I will share the link. I mean, let me share now also. So what you can do, you can like practice also. So for practice, what I do, I actually like hide this one, and then you can create a new cell here, and you can write your code here. And when we say hide this, so just hide the code like this. So based on the query, try to after following up to this point, try to write your code and see if that is working or not. And then you can also see the code that actually is doing that. So this is a question, and we have to find the answer for that. So it's a good practice, and I think 4, 5, 6, 7 questions are there. So that way you can practice. Yeah, 4B, 4, 6A, 6B. So they are like good questions, good set of questions, I would say. So what is happening? Let me give you overview. So it's like one operation is like average, min, max, just like SQL. And then year operation is also, I think code is gone away. Oh yeah, this is a code. It's like again the hiding cell and all. So it's like this is a one where we are applying year also for extracting the year. In SQL also, if you remember, we apply year to extract the year. And then here week of year, again another operation of that. Nothing new. I mean, we actually did all this. So then yeah, this is new. So what we do, if you want to save your data frame, so we can see instead of load, we can say write. So it's like Spark read CSV. This time we are saying Spark write and format. We are saving in Parquet format, and then we are also defining append or overwrite. We are saying overwrite. So that means if data is already there, we are overwriting that and the location. So I will explain this more, like what this format is. So it's something different which you not see in pandas and Python way, but this is very important. We call it hive partitioning and all. So I will explain it more in depth in this way. But let me share the URL, Tahir. So this way you can get this access to this particular notebook. And yeah, let's practice it. So let me share it with in the group so that Tahir can, Fazit can share. Yep, I shared in group. So Pawan and yeah, Pavan, you can like get the link, and also you can practice it there, like creating the community edition, or if you just want to like walk through the code, that is also fine.
Yeah, okay.
Yeah. So we will meet tomorrow then. Yeah. Thank you for joining. Bye.
Thank
Bye
you.
bye.
Thank you.
Bye
Bye.
Pavan.
Bye. Bye.